All right. So nuclear charge is really the concept that explains a lot of these trends. Okay, so that's why it's important that you have like a good grasp on nuclear charge, what it is, how to describe it, and then how to use it with these trends. Because this year you need to go beyond, beyond the idea of like, oh, this increases down, that decreases across, and really explain why. Okay, so the first one we want to talk about is the size of an atom. Okay, I think it's easier just to look at the periodic table, for example. So we're not going to go through these slides necessarily because you looked at them already on your own. All right, so let's talk about the size of an atom. Okay, so look at lithium and sodium for a second. Think to yourself about lithium and sodium. Which one's bigger and why? Okay, so find lithium and sodium on the periodic table. They're in the same column, and think about which one's bigger and why is it bigger. Okay, take a minute. Sydney, you're about to be on camera. You good with that? Oh wait. You sit back here, all right. Okay. So, tell me about lithium versus sodium. What does lithium have?
3 protons.
Lithium has 3 protons, and sodium has 11. Okay. And that's in their nuclei, right? Okay. Now, which one's bigger? Sodium or lithium? A sodium atom. Why? It has more energy levels, okay? If you think about lithium, it's 1s2, 2s1, right? Sodium is 1s2, 2s2, 2p6, 3s1, which means lithium only has 2 circles around its nucleus, right? 2 energy levels, whereas sodium has 3. And that's why it's bigger, okay? So when you're going down a column, you're adding energy levels, okay? Which means you're, by default, increasing the diameter of the atom, correct? So that's why it increases going down. That would be your reasoning, okay? Because you're adding energy levels. What happens when we go across, okay? So what happens, for example, when we use, let's look at carbon versus oxygen, okay? So talk to me about carbon. What does carbon have in it?
6 protons.
6 protons, okay? So here's its nucleus. And oxygen has 8. Okay. Now, sketch these for yourself on either on paper or Notability, and think about what else they contain, and what we can do there. Better. Just don't back up.
Okay.
So we'll have $1,000 worth of problems. No pressure. Oh, but that's too close. Hold on. Simran, really, don't back up. There. Okay. All right. What does carbon have? 2 energy levels, right? How many electrons are on the first one? 2, right? Because that's 1s2. And then how many energy levels are on the second one? Or how many electrons are on the second energy level?
8.
No.
4.
4, because it's 2s2, 2p2, right? So 1, 2, 3, 4. So 6 electrons total for carbon, right? Now let's talk about oxygen, okay? What does oxygen have? It has 2 energy levels also, There's 2 electrons here. And then how many does it have on that second energy level?
6.
6. 1, 2, 3, 4, 5, 6. So its configuration is 1s2, 2s2, 2p4. Okay? Now take a minute and think about the size. Which one of those is going to be, you can pick, bigger or smaller, and why? Okay? And actually, let's just think about it going across, like going left to right, going from carbon to oxygen. What's happening to the size of the atom and why?
Decreasing.
It's decreasing.
It's decreasing.
As you go across, there's more photons again.
Exactly. As you go across, the size is going to decrease because they're at the same what? Energy level. But as you go across, there are more protons in the nucleus, which means the 2 words, what are the 2 magic words? Nuclear charge is higher, right? The nuclear charge is higher, so that nucleus is able to pull in that outer energy level better, right? We're looking at the same energy level for carbon as we are for oxygen, energy level number 2. The difference between them is that carbon only has 6 little protons and oxygen has 8. So the oxygen nucleus has a higher nuclear charge and it can pull in those outer electrons a little tighter. Okay? That's why atomic size decreases left to right. Got it? Okay, now let's talk about ions. All right? What happens